again. I hope the code sprints this morning were helpful. We're going to go back to web components today. We're on day 3. And so today we're going to dive into those remaining technologies. We sort of spent all of yesterday on the Shadow DOM, which is good. The Shadow DOM is probably the biggest and kind of more complicated part of web components. We're going to get into the other pieces today and pull them all back in and see how they all fit in together. All right, so what we're going to start with is HTML templates. So what is a template? Oxford Dictionary calls it something that serves as a model for others to copy. Right? We have templates outside of just software. We have templates in all sorts of fields, and we talk about things as being templates for other things. But this is a model, and it's a model that we copy, and that's the same definition loosely that we use when we talk about templates on the web as well. So a template is essentially a blueprint. On the web, the way we use a template is we have a blueprint we call render, and we get HTML. And the analogy there is a blueprint to an actual built house. Right, so we have a model that can be reused to build an instance of something, to copy and build an instance. And we can build a whole bunch of instances, right? We do this over and over and over again. And on the web, we do that by calling render. Render is the important piece of that. So a very common form of templates is called mustache. How many of you use mustache templates? All right, so we get a few. Mustache templates, or variations thereof, are used in a lot of JavaScript frameworks. Handlebars is used in Ember, which is a variation on mustache. Of course, mustache is called mustache because the curly bracket looks like a mustache. It took me a while to get that the first time. When we talk about using mustache templates on the web, templates here, or any sort of web templates, they serve two purposes. Their first purpose is to pre-render a string replacement in markup. So let's take a look at this again, right? We have this placeholder name. And so we want to replace that string here, that placeholder, with a string, with a piece of data that we have. And the other purpose is sort of as a transport format for this markup that's not rendered, right? This isn't going to be on our page yet. We're going to do the whole call render thing before we get it on the page. So we have kind of these two pieces of it. And so a normal way we use mustache templates to do this kind of replacement is we have a template string. This is JavaScript. We have a template string. That's a string with our HTML and our template replacement notation. And we have a data object, or just a plain old JavaScript object with a key name and a value world. And then we have our actual output that we're going to put on the page. And we do that, we generate that by calling mustache. We have a mustache library that we've imported. We call .render. And we pass in a template string and the data. And once we have that, the output of that function is going to be h1 hello world. It's now replaced name h1. So now we can take that and we can add it to the page. Yeah?
Can you slide back a slide? I don't know. Are you going to get to the second point there? I wasn't clear what that is.
Yeah. So I mean, my kind of description for this, and these are my own words, so they may not be as precise as they could be. The question was, what exactly is the second thing here? You don't need actually any replacement here, right? If I hard-coded world, I wouldn't need that. But mustache is still the kind of format that I use to transport that template, that HTML, that unrendered markup, because it's not rendered yet. It's not on the page. So yeah, I mean that's kind of the format, right? But we don't have a way to add it to the page, to add this portability, this portable piece of template, this portable string essentially. We don't have a way to put it onto our HTML page, and so we figured out some ways around that. And we've been sort of creative with this. And depending on where you are and how you use mustache templates, you might have seen different ways to put this template onto your page, to include it somehow. Some people do it with a hidden div. So they create a hidden div on the page, and they say hidden template, and then they have their template content, right? But we don't want this actually on the page yet. We just want it there so we can use it. And then we do document query selector, select the hidden template. Oh, we need a dot there. I've got the dot. Template string, is going to be the inner HTML of this template. There are problems with that. The big problem is this right here, right? What if I have an image in my template? Yeah.
So I guess I'm still struggling with the concept, like, but no transport mechanism. Like, I'm not quite sure what that is. I totally get templating
Yeah.
and form letter, insert customer's name here, run that for all the customers in the database.
There's no canonical place to put it, to put that HTML. So we can do it in our JavaScript, but that's messy.
Okay, so
There's no
when we
place
were
to put
using
it.
Mustache, we created a little template right in our HTML, and then
Exactly.
we got that, and we used it.
But a lot of times we don't want to put that in our HTML.
So by transport
or in our
mechanism,
JavaScript.
like, where do we store our templates?
Exactly. Maybe storage spot would have been a better description there. And so the problem is if we store it in HTML here, and we store an image, what's going to happen when the browser gets here? It's going to actually download this image. So in the browser I'll actually see that foo.jpg was downloaded, but I haven't actually used this template at all. I might never use it. And so I've now downloaded an image that I might never actually use. And this can be problematic if I have things like a style tag in here, or I have scripts in here, or a whole bunch of images that are big and it'll take a long time to download.
Yeah, it just impacts performance.
Yeah, and it's generally just it's just a bad way to do it. So we have another method. This is the overloaded script tag. So this is where we take a script tag and we treat it as a place to put our template. We call it we just make up a type here. Like text HTML doesn't really mean anything. It's not JavaScript, so the browser won't execute it. And then we do the same thing as before, inner HTML the script, but this is a script, so fortunately, if we have an image there, it's not going to be downloaded. So it's not actually that bad. This is actually not a bad way to approach it. But it still feels sort of like a hack, right? We're kind of abusing the script tag. It's not sort of what it was meant for. I say not actually that bad because this is actually one way to do it. This is actually probably how a lot of people add scripts into HTML today, if they're not including it via JavaScript or add templates via HTML today. But it was sort of what the template was meant to address.
Sorry. So I just want to look at this code here for a second and understand it. I know this is bad video because you can't hear me, but we just kind of do a little bit of a walkthrough there. Because when you're talking, it's like I can't take in what's on the screen and listen to you at the same time. I kind of need you to stop so I can read the screen, and then and then I can focus that, and then I can come back and focus on you. I can't do both.
Yeah.
So
The question is, can we use that
template L, and we're just getting an element by ID, and template string. An element we give by ID is all that stuff inside.
Yes.
We're getting that entire element, and then we're saying template string is equal to that stuff's inner HTML. Okay, that makes sense.
Yeah, so the question is just, can we spend some more time on this code? Yeah, and I think that's helpful. So, just to reiterate, we have a script tag. The script tag is not text JavaScript, so it's not going to be executed by the browser. It's just going to be sort of sitting there. And then we have an ID for to access it. We have our template within here, but nothing's happening there, so you're going to have an image tag so it can get downloaded. I have a variable for that element, for that entire script element. And then I have that string, which I just get via inner HTML of that script.
And so if you have image tags in there, they don't get downloaded.
No, because the browser is not really, this isn't JavaScript.
Okay.
And it's not in HTML, so nothing's going to happen.
Is that the recommended best practice now?
If you need to store it in HTML, that's how a lot of people do it. Calling it a best practice is probably going a step further than I would. Normally, the best practice is not to put it in HTML at all. It would be just to import it via JavaScript, via a JavaScript module. However, if you want to have it in HTML, this is probably the best way to do it. There are some security concerns with selecting the inner HTML of a script and then executing that. I think in a lot of cases you can kind of treat it as trusted, so that's not a problem. Yeah, this would probably be, it's definitely better than this, a lot better than just doing a hidden template.
Okay, cool.
It is sort of hacky though. So this is sort of the gap that HTML templates were trying to fill. It's not, I understand if it doesn't seem like this is actually that bad, and I kind of agree with it to some extent. So templates are kind of a nicer way to do it, but you know, there's certainly other approaches. So where do templates come in? So template is this new element that we have in HTML called template. Now we can just set our template within our template element, and this is completely inert. So it's not doing any. So let's step back. It's a new element. That's the first thing to notice. The second thing is it's only addressing like that transport mechanism or storage place or the place where we put our template, whatever we want to call it. There's no string replacement or formatting. Template doesn't do any of that. Template isn't doing you know, curly name, and that wouldn't do anything. It would just be treated as HTML. All the template tag is a place to put content. We could potentially do something after the fact with that, use something else to do that string replacement, but that's not built into template.
So that's got 67% support in browsers right now.
Yeah, there's actually it's better supported than our other web components features.
Yeah.
It was sort of less controversial.
And then you used template in one of the first examples we saw on Monday.
Yep.
So you put this just in a separate little file, actual file, or
Yep.
you'd store it in some sort of object. You'd have all these template strings that you could pull out.
So that's part of our HTML imports, so it can be in a separate file,
Yeah.
and the template goes in that file.
Right. But people don't probably use template in production today because of only 67% support.
It can be polyfilled.
Okay.
So it's actually one of the easier things. I think the polyfills work fine out of the box for more than the shadow DOM. So that's actually something that's fairly easily polyfilled. Because it might not be a perfect polyfill, like maybe it's still going to, maybe some things are processed that it shouldn't be. I'm actually not exactly sure of limitations, but it's not, it's always going to work. So with our template, how do we access what's in the template? We have our template, then we're going to do document.getElementById or query selector or whatever you want for my template. And then you can access the content of that template. So we're not interested in the element itself, we're interested in what's inside. And so there's a content property on that template object. We get .content. So that's my template content. And then we create a clone of that template. This is where the magic happens. When we clone our template, that's when it comes to life. That's when it suddenly starts downloading any images, running any styles, and it actually, you can do something with it. So document.importNode is going to clone that node. So it passes that node as the first argument. And then the second argument is true. So the second argument is just a boolean for whether that should be a deep clone or a shallow clone. Import node is used for other things than just templates. But when we use it with templates, we always want a deep clone, so this will always be true.
That's like a general, universe for global versus not global?
No, it's just a clone of an object beyond the first level. So what we're doing is we're cloning this entire node here, but if we have like a whole bunch of nested objects, we want the entire thing. We want a deep clone. So that's just setting it to be a deep clone rather than a shallow clone. But yeah, shallow clone wouldn't be that helpful here. So.
What's the difference between content and our HTML?
You know, that's a good question. I believe the difference is that inner HTML is getting you a string, and content is going to get you nodes. I'm pretty sure. We can check MD on that. So when you import node, right, you want to be importing nodes, not strings.
So what if you had, so when I think of a node, I think of DOM, I think of like, okay, here's my H1 node, right? So if I'm getting content from my template, well, okay, there's only one node, it's H1. What if I had an H2 in paragraph?
Yep.
Would it get all three nodes, and then
Yep.
all three nodes are stored in template?
Yep.
And then when I import node, it imports all three of those nodes.
Yes.
Okay.
Yep. Actually, I'll confirm really quickly here. MDN content node. We don't want text content. We want content. MDN does not have a page for that. I will find the page after, and we'll confirm. All right. So 3 steps here. The first step, getting the template elements this content property. It's going to give us those nodes. Second one, copy that content node with the import node method, and it's going to be deep clone with that true. Oops, and
I keep thinking something went wrong. Oh, we lost power.
I have a button here that just turns everything black, so he's slipping me in that. And then I have, then once you do all that, then you actually need to put it into your shadow group. We usually want to put it into your shadow group in the context of the shadow DOM. But I could append this anywhere if I weren't using it with shadow DOM. I could just append it on my document. But basically any element here, dot append child, and now I'll append my clone. So usually shadow root in the context of web components. So yeah, template contents are inert. That's the important piece here. Not inert like the noble gases. Inert in the sense that scripts aren't executed, resources aren't downloaded, and styles don't have any effect. CSS won't have any effect. JavaScript isn't executed, resources aren't downloaded onto the page.
Scripts aren't executed, resources aren't downloaded.
So resources are like images. That's going to be the big one. Videos, maybe any media that you have there. Until they're cloned. So once we do that import node, now all of this stuff kicks in.
All breaks loose.
Yep, it all comes to life.
If we have can we use templates with mustache, and then when we render it, right, would it then inject?
Yeah, there could definitely be ways to do that. Where you
It
just
seems like if you're replacing same with same, because this is a replacement for mustache, right?
to some extent, it's a replacement for mustache. It could certainly be you could put mustache in here, and then you can do client-side replacement. In fact, I think next week when you do Polymer, you're going to see some ways that you can do templating with Polymer with templates, with like a similar syntax. But template tag on its own doesn't do any of that. So what changes? We've been writing this all week. We've been writing a lot of shadow.innerHTML plus equals, shadow.innerHTML plus equals. With templates, we can move this inner HTML into our template tag, access our template, we have our shadow root, and then clone in our template and append that to our shadow root. So we're going to stop writing that inner HTML plus equals and the shadow.append child, document.create element. We'll stop writing all that. We'll start putting in templates because that's a far nicer way to write it rather than having to do function calls. And we'll just have some boilerplate code here to grab that and append it to our shadow root. And where does it go? That's HTML import, so we're going to go into that next. But are there any questions on HTML templates?
I guess just like a little bit of a talk through on that code. And I've talked through the last couple. Would somebody else like to just read that bottom block of code and explain it in your words? I find that that's helpful for me.
Yeah. Okay, so what's happening in this first line?
Let's get a student. Talk through it. Who wants to do it? Because I know if you don't step up, you're going to have to listen to me. All right, do it, Bob. Talk through that bottom chunk.
All right, first we're creating the variable template, which is going to be the content of the template ID. And that's it's whatever is within the tags of template ID, the ID template, but not
Yep.
the template itself, but just the stuff between it. All
The
of those
nodes.
are there.
Yep.
Content gets the nodes.
Yeah, it's the nodes. Then we create shadow root with what we're very familiar with already. Then we create a variable clone and import the node. Oh, we import what we just created, which was the content of template, and we insert those nodes, and then we append all that to the shadow root with that append child.
Nicely explained.
And I got a
Awesome.
question.
Yeah.
So who could explain what the true means on the third line?
So it doesn't default to, let me check my notes.
What's true to? or something, right? Or deep
Yep.
what?
Deep clone.
Deep clone, there you go.
It's gonna give you a clone, and that means it's a deep clone rather than a shallow clone.
And what could be funky about line 2? What's funky about line 2? A little bit funky. It'll work, but it's a little bit funky.
I'm not sure where you're getting at that either, so.
Or right there, Dr.
So a shadow is a class. A class could be many items.
Sure.
A query selector selects one item. That's a little bit funky, right?
Yeah, this is sort of a placeholder if you have, you need to select the item you want to put the shadow root onto. Yeah, that's
You
true.
could have like 4 shadows in there, 4 classes of shadow, and you just get the first one in your DOM.
Exactly. This might make more sense to put as an ID,
Or a query selector all and then iterate. through
or
it.
iterate through it, yeah.
Yeah.
What's gonna happen, we'll see with custom elements that we can ensure that that's one element, so that won't be a problem. But, yeah, if you're just doing this without custom elements, then, that might be weird. You'll only get one.
So I just also want to provide a little context, which clicked for me yesterday, and if you could bring up if MDM web components, please, Andrew. And then at the very bottom on this page, very bottom of the page, up just a little bit, not the very bottom, I guess, up a little bit more, up a little bit more, right there, top, those 4 things. So those 4
Yes.
things right there, we have custom elements, we have HTML templates, we have shadow DOM, we have HTML imports. So these are all new HTML5 technologies, right? Custom elements, templates, shadow DOM, imports. And when you hear people give talks on web components, they quickly say web components are possible, we can do that encapsulation and stuff because we have these new technologies. And we've been looking at the shadow DOM. Now we're looking at templates, right? And now that you've created a template, and we saw this in Andrew's example the first day, I need to import that onto my page, right? So we can import that HTML template that we created, and then we could do custom elements to call, like whatever my dash button is our new tag, or image dash slider, my image dash slider is my new tag. So we can create custom tags. So those are the 4 things. This is HTML5, is that right, Andrew?
Yeah,
These 4 things.
sometimes with HTML people don't like to use the numbers anymore, 'cause it's a quote-unquote living standard.
That's passe.
But, yeah, and these are kind of post, original HTML5, like these come a little bit after.
Okay.
Yeah, these are all new HTML technologies. And again, they're not like finalized too, as we saw yesterday. All right, like I go here and we see, HTML imports working draft, shadow DOM working draft, custom elements working draft. See living standard here. But they're certainly on their way. And yeah, these are the 4 pieces. We've been kind of getting through them slowly, kind of one at a time. I think it's important to dive into each one of them and understand they work on their own. But web components is when we pull all these 4 together. Exactly.
How many people show of hands that was helpful? And I don't know this stuff. I know a little bit.
Yeah.
And so whenever I say something wrong, just go, no, that's not quite right.
No, that's helpful. It's good to slow down and kind of remind ourselves, what are the pieces of this. Shadow DOM is a big one. That's why we spent some more time on it. Templates is a little bit smaller. Imports a little bit smaller. We'll go to that today. We'll spend a lot of time tomorrow on custom elements, or this afternoon on custom elements as well. So.
Scroll to the bottom of the page again there. All right, here's another question for everybody. We've got custom elements, we have shadow DOM, we have imports. What's the 4th piece that's not shown there? There's 4, what's the 4th one?
Templates, I heard it, yeah.
Templates. It's kind of hard, huh?
It's hidden right down here because it's, so they actually put it as part of the HTML5/HTML5 living standard. But yeah.
All right.
these have been around a little longer, so they're not the orange here. They're, because it's actually a recommendation in the HTML5 W3 spec, and it's part of the standard in the Living Standard. All right, so we're going to dive into imports as well right now, and then we're going to go ahead and start writing some code. I think it's helpful to see kind of both of these together because they go together so much. So where does this template go? How do we get it into our page? This is where HTML imports come into play. So if we want to import CSS, how do we do it? There's this one tag we use. Does anyone remember what that is? Link, exactly. And we do link rel style sheet, right? Exactly. Link rel style sheet, and we give it a reference, and we can say, you know, something.css. If we want to import JavaScript, what do? Script, exactly. We say script type text JavaScript, and we import JavaScript. If we want to import HTML, we don't have any method for that. Until now, HTML imports is the method for importing HTML like we would with CSS or with JavaScript. So the important thing to remember here is link, rel import, href, and our HTML document. This might look like a link like you would use with CSS, but it's not. It is a link element, but you have to have rel import there, and that's how we know which HTML imports. And it's actually going to download this document here. Rel import is important. .html. This is not a CSS document.
Is this only in the head? Could you only put this in?
You
your
could
head?
put it anywhere.
Anywhere?
It would work anywhere.
It's based on when you need it in your page.
Yeah. It would make sense to go in the head. They are, depending on the browser, they're going to be, they might be blocking requests because they could have CSS in them. And because CSS can affect the document, to minimize the flash of unstyled content, they're going to want to block all the other resources. You can use async as well if you know that's not going to be an issue. So when you actually do that and the browser processes that HTML, it's going to go ahead and make a network request. The way you can debug this is go into the network tab in your DevTools, and you'll see all the different types of requests that the browser can make. XHR is AJAX requests. Script are JavaScript requests. Style is CSS. Images and media are images and like videos and stuff. Fonts are fonts that you're downloading. You have WebSockets. How many of these WebSockets? All right, WebSockets are a way we can just sort of do like pushing data to the browser. And so when something changes, the server tells the client that something's changed, and you can listen to those. Yes.
Isn't that what Firebase uses?
There are WebSockets. There's WebSockets that port with Firebase. Yeah.
Oh, never mind, actually.
Okay, cool. And then other things. But there's this big documents one here, right? And we're always going to get that original documents one for pulling down the page, right? But then we have here when I include foo.html, I'm going to get that as a request now, and I'm going to have my normal download information, and the browser can be smart about how it requests this. So this is sort of a native way to download something to the browser, so it's actually going to be faster than your normal XHR requests. Yeah, the document piece is important here. This isn't a script. This isn't a style. It's not an AJAX request. This is a native document request.
But it's another round trip, right? At the HTTP level.
Yes. Until HTTP 2, but we can get into that.
Yeah.
Could we diverge into that just right now, otherwise we might forget? What do you know about HTTP 2 and where is it when?
I will have a slide on that, so we'll get to it in a second.
Awesome. Cool.
Yeah.
It's coming. I thought it was going to be a tangent.
Yeah, we will, because it is kind of relevant to this. So sub-resources are also back. So I have my document here, but then if my foo.html has a script tag that says foo.js, well, now it needs to download that script, right? And so now it's going to make another request, but this time under script. It's going to download foo.js, and the initiator here is foo.html. The initiator is important, because that's where it was initiated from. It's not the main document anymore. It's going to be this sub-resource. So we call that a sub-resource, because the first one was a resource, now everything else is a sub-resource.
What about style, the style tab right there? Because when we call style, we don't have a style tag, right? We have a link tag for style.
Yes. So when document, the download's going to show up in style. So if you open up a normal page, I recommend if you haven't used the network tab much, open up a normal website, you know, Twitter or Facebook or Google or whatever it is, and open up the network tab, reload it once you open it, because sometimes those aren't recorded. Reload it once you open it, and you'll see everything that's downloaded, and you'll see kind of this nice little waterfall. We can look at that a little bit after, and it will show everything that's downloaded. And if you select all here, you can see everything, but then if you select script or style or images, you'll see the specific ones. And JavaScript is executed. So what happens with an HTML imports is we download the resource, we download the sub-resources, and JavaScript is executed within that import. Alright, so some important kind of quotes that we should read through here. The script in the import is executed, this is Eric Bauman on HTML imports. Script on the import is executed in the context of the window that contains the importing document. So window.document refers to the main page document. That's important. So window.document is not changing. So your document dot is not changing. That's going to still be your main document because the script is executed in the context of that window. This has two useful corollaries. He goes on to say, functions defined in an import end up on the window. So if I set a window function, that ends up on my main window. It's not like some sub-window. There's one window. And then you don't have to do anything crazy like append the script's import blocks to the main page. So the scripts get executed in the main page. We don't have to worry about that. I know that's a lot. Hopefully we can come back to that as we sort of play around with it, and if you see any weird behavior, you can take a look here. But the main piece is that document refers to the main page document. So when I want to access my current document, I import a document, I have to do something special here. I have to do document.currentScript, and that's the current script I'm executing, which is in my imported document. And then I have to do owner document there, and this will give me the HTML import document. And we've seen that in the boilerplate code that we used for the example on Monday. But this is why that's the case. Because if I just wanted to do like a query selector within my HTML imported document, I wouldn't be able to access those nodes because they're not there. Document's my main document, and then if I want to get the imported document, I need to go to current_script.owner document. There's a limitation with a polyfill here, in that you need to do _current_script. So the way you access this in the web components.js polyfill is you have to have _current_script. The workaround for all of that is that you just check if _current_script is defined. If it is, you use that. Otherwise, you use current_script. All right. Any questions there? I know this is a little bit, there are like multiple documents spinning around here, and it's not clear exactly where everything is. But just keep in mind, document is going to be your main document. And to access the imported document, you need to go to document.current_script.owner document. All right, so what are we on the performance here? You brought up a good point about round trips. So the colors don't come up here, but these sort of like, faces are supposed to be yellow, and these ones are supposed to, the happy ones are supposed to be green. Alright, so the first int is that each new network request has a price. So what we can do here is concatenate our imports to reduce requests. So we can at build time, when we're saving our site and putting it up to the web, we can build them all together to a single file and just do one import and just make one round trip request. We're going to do that on Friday. We're not going to do that today because that's only a performance concern. For development, it's fine to do it just all locally independent requests. Imports block rendering. So they'll block rendering because they want to prevent that Flash 1 style content. So they don't, because you can have CSS in your actual imported document. The concern is that you'll get a Flash 1 style. You'll have things that are unstyled if you don't block rendering. So we'll talk more about Flash 1 style content when we get to custom elements. But just know that the browser tries to block that to be safe about things, but that can have performance implications. You can use the async attribute, which will mean that you'll basically tell the browser, hey, don't worry about blocking anything. Like, I'm giving you permission to go ahead and just like start rendering these as soon as you get them. The reason that isn't default, and you have to be careful about it, and the reason I say if possible, is because if you have any cross dependencies between these imports, then you can't just have one render, have another one render at the same time, or you might be missing a dependency there. One relies on the other. HTML, so this is a pro on performance, and a big pro with HTML imports, is that HTML parsers, the parsing of that actual HTML document, can be run in parallel by the browser, which means that the browser can run these at the same time, and this is going to be more performant than if you did one after another after another. And so that's a positive. I have this little asterisk, and it's for until HTTP 2. We won't go into too many details on HTTP 2. It's getting there. It's the new specification for HTTP 2, for HTTP, the transport mechanism we use for transporting things over the web. And HTTP 2 is fully multiplexed. So instead of ordered and blocking, it can use one connection for parallelism for multiple downloads. So what that means in practical terms is that if I make multiple script requests, right now that's bad because I have to do a round trip for each one of them to the server to get those scripts. With HTTP 2, we can open up parallel connections. Well, we'll have one connection, but we can make parallel requests over that same connection, so you're not going to do as many round trips. I'm no expert on HTTP 2, so I can try to answer any questions, but this is a link. It's a quote, actually, to in the document where I linked to it from. So if you click that, you'll get information on the FAQ for HTTP 2 with a whole bunch of fun questions. Like, why is HTTP 2 multiplexed? Why do we need
So
headers?
with HTTP 2, I know you're not expert related to WebAssembly then?
No.
No.
It's, I mean, loosely because they're both on the web, but yeah, they were different things.
What does the HTML parsers can be run by browser in parallel again mean?
So parsing is when the browser has to go through and look at your HTML and like figure out the structure of that. So it's looking at one big string and now it has to parse it into something that it can understand. It can do these in parallel, which means that it doesn't have to just do one at a time, it can do multiple ones at a time with HTML imports. And so that's kind of a new performance benefit we get. That's just something that has to be done before I can do anything with the HTML. But there's some controversy, like a lot of things in web components, over HTML imports. This is a blog post by DJ Van Tol on the problem of using HTML imports for dependency management. HTML imports transfer the dependency management burden from component consumers to component authors. This sounds good until you think about how to reconcile those dependencies. So what is he talking about? So, say you have a script tag in one HTML import, and you have a script tag in another HTML import, and they're the same exact thing. Yay, HTML imports is smart enough to handle this. Because what it will do is deduping, which means it will it'll notice that the second script tag is the same exact one as the first time, and it'll just say, well, that's a duplicate, I'm going to move on, I already downloaded it. I don't need to download it again. And this is going to be a problem as you start having, or it would have been a problem, right, if we didn't dedupe, because as you have more and more of these scripts, more and more of these components, they're all going to be depending on potentially similar things. For example, let's say you have multiple components that depend on jQuery, as I have here, right? The first one will pull in jQuery, the second one will pull in jQuery. jQuery is not small. I mean, it's small-ish, but you know, it's still a sizable library, right? And so I'm downloading here, especially jQuery 1, because that has like old browser support. I don't want to have to download it twice. So cool. If I download the same exact thing, say I'm using this CDN here, then I'm good. All deduped. Until this, one component decided it was going to download jQuery from another URL. It was downloading it from a different CDN in here, Google API's CDN. Well, now browser has no idea that these are the same thing. Like, you can't just say, oh, jQuery's in the name, it's probably the same thing. So even if they're exactly the same script, it's going to have to queue downloads here, and that's a problem. And they might not even be the same script. They could be different versions, for example. And now you have to deal with, you know, jQuery 1 and jQuery 2. Which one do you download? Do you download both? Well, you probably do, because one component could be relying on one, and one component could be relying on another. So this is a problem with HTML imports that aren't really solved. You move this dependency, as DJ mentions in this blog post, you move that dependency management, which is that problem of managing those different dependencies, from the component consumers, you building a website and using different components, to the component authors. And the problem is those component authors aren't coordinating on their dependencies, you know, when they put their components out for use. And so maybe if you're using all your own components, that won't be a problem. But a lot of times you're going to be using components that are written by third parties,
Yeah.
in which
Yeah,
the case
but
this is a problem.
That was kind of my question too. I'm like, wait a minute, aren't you the one controlling these imports? But the imports could be another dependency based on your program.
Exactly, and we'll talk more later today about different components you can use, different third-party components. That's really, you know, we've talked a lot about building our own components, but we're building components not just for our use, or maybe you are right now, or in your company, or whatever you're building. But there are a whole bunch of components out on the web, right? And the idea is that people want to share these. And that's not just like that would be nice to have if someone shared it. It's in fact the case that people share components quite a bit, just like we have open source libraries like jQuery and Backbone and whatnot that are open and shared and created and available to use. Components are the same way. And the problem now is if you have multiple components that have different dependencies. This could also happen if you write components. You know, what if you write a component and, you know, it's 3 months later you happen to write another one but use a different CDN. Now you have an issue. And this can quickly multiply depending on the number of components you have. This is Firefox on their Mozilla Web Components update in December, and they've affirmed this position in an update in April. Mozilla will not ship with an implementation of HTML imports, period. We expect that once JavaScript modules, a feature derived from the JavaScript libraries written by the developer community, is shipped, the way we look at this problem will have changed. So I alluded earlier to this idea of templates, and we, you know, a lot of times with templates we just include them as JavaScript modules. The same thing, you know, can be said for everything else that we need to send over the wire with HTML imports. And so Mozilla's criticism here is that HTML imports is a cool idea, but let's hold off until we've actually looked at how we're going to use this new ES6 module feature, which is going to be in browsers very soon, we've already agreed upon. Wait until that's shipped, that's in browsers, and then let's reevaluate this. Let's look at this with kind of new eyes, and Mozilla's betting that we'll look at it differently, that we'll think of better ways to handle things like dependency management.
So, JavaScript modules, is that ES6?
Yes.
And JavaScript modules, is that another way to do componentization of HTML, CSS, JavaScript?
So it's a way we do componentization of JavaScript. So
It's a what?
of JavaScript. Componentization of JavaScript itself.
Only JavaScript.
And I showed the syntax on the first day. I can pull it up again from the presentation on that. If you remember that import-export code that I showed, that's that ES6 module. Let me try to pull it up here. Day 2, not day 2, day 1. We've had a lot of slides. All right. Let's see. Here we go. JavaScript. So when we talked about JavaScript interfaces, JavaScript encapsulation, and JavaScript portability, when we get here we say we have a script element, and then we have a way of importing these modules. In that, in the past what we've been doing is we've used something like AMD, with require.js to do modules. We use CommonJS on the Node.js side and also with Browserify. But both of those are sort of being replaced with our ES6 modules that look more like this, where we say import something from a module. So these are ES6 modules. So we have this already agreed upon. ES6 passed, wasn't a finalized spec about maybe 2 weeks ago. So that's a thing now. We've agreed upon that as a JavaScript community. And so browsers are starting to implement these. Modules are taking some time, but they're almost there. We've already agreed on all the final semantics here, the final syntax. It's just a matter of getting it implemented. And so, Firefox's, kind of request here, or suggestion, and it's a suggestion they can make with a lot of power, since they control the features on a major browser, is that, let's stop on HTML imports. We don't need yet another way to download things into our page. We can do this with JavaScript. So while JavaScript modules, ES6 modules, only import JavaScript, it's fairly trivial to put HTML into our JavaScript. We've been doing it all week, right? We've been putting it in strings. That's not difficult to do. And so why don't we revisit this feature once we've been using ES6 modules for a while. That's their perspective there. Maybe that will change. Maybe conversations will happen in the near future that will change their mind. But this is where they are. This is where they stand on the decision. It's not just that they're taking the time. They've made the decision not to ship HTML imports, for now at least. So, but it's still in Chrome. All of these web components features are in Chrome, and so we can use them. I added a little for now in there. There's still discussion here, and if we end up deciding that HTML imports aren't the way to go, that might disappear, but we'll see. So